Hello all, let's start with chapter number 12, electricity. So in this video I would be covering some previous year questions related to chapter number 12 and they actually are of 3 marks only. So let's start with it. Question number 1 says list the factors on which the resistance of a conductor in the shape of a wire depends. So there are two factors, that is length and another is area. Now, in the case of length, you have to write directly proportional, and in the case of area of cross section, it is inversely proportional. So write like this, that R is directly proportional to length and R is inversely proportional to area of the cross section. Then in the end, you can even write R equals rho LA. When we remove the proportionality sign, we get a resistivity here, resistivity sign, that is rho. Now moving on to second part, it says why are metals good conductor of electricity whereas glass is a bad conductor of electricity. You know, metals are good conductor because they have large number of free electrons in it and their low resistivity. Due to their low resistivity, they are considered to be as good conductor of electricity. Whereas in the case of glass, it has no free electrons in it and therefore the resistivity is quite higher as compared to metals. That's the reason metals are good conductor and glass is a bad conductor. Now question number C, it says why are alloys commonly used in electrical heating devices? Alloys are commonly used in electrical heating devices because of their high resistivity and high melting point, which produce more heat in return. So that's your answer for C part. Now moving on to next, it says name and define the SI unit of current. Name and define. So you have to define ampere. So 1 ampere is actually 1 coulomb charge flows in 1 second in a conductor, then magnitude of current is said to be 1 ampere. These all SI unit are very important in terms of board and you have to remember the definition of all as well. So I, as you know, is Q over T and Q is in coulomb and time is in seconds. So therefore we have 1 coulomb charge flows in 1 second in a conductor. Then it is said to be 1 ampere. Now we need to tell the second one, calculate the number of electrons that flow through a conductor in 1 second to constitute a current of 1 ampere. So we need to find the number of electrons. For finding number of electrons, you need to remember one formula, which is Q equals Ne. Q represents charge here, N represents number of electrons present, E represents the charge of an electron, that is 1.6 into 10 raised to power minus 19 coulomb. So in this, when we reciprocal it, we get N equals Q over E, and Q can be written as I into T. I is given, that is 1 ampere, T is given, that is 1 second, and we have E as 1.6 into 10 raised to power minus 19. Now when you solve this, you will get your answer as 6.25 into 10 raised to power 18 electrons are there when we have 1 ampere of current and 1 second. In 1 second, the number of electrons that flow through a conductor is 6.25 into 10 raised to power 18. Now moving on to next. It says study the VI graph for a resistor as shown in the figure. We have VI graph here. Find the value of current for V equals 10 volt. How can we determine the resistance of the resistor from this graph? So basically we can find the resistance by using slope. So how to find slope? They have taken 2 points, this and this. So for this coordinate, my coordinate will be 4, 8, and for my this point, let it be B and let this be A. So I need to find the slope of this AB. So here it is 3, 6. Now as we need to find the resistance, so resistance will be change in Y, that is 8 minus 6 over change in x, that is 4 minus 3. So this will be 2 ohm. Now we need to find the value of current for volt. V equals 10 volt. Now as you know, V equals IR. So V is 10 and I in this case we need to find R is 2 ohm for this whole equation. So I in this case will be 5 ohm. The current will be 5 ohm when voltage is 10 volt. So that's your answer for this question. Moving on to next, it says explain why a conductor offers resistance to the flow of current. So conductor actually has number of molecules in it. They produce an hindrance in the path of flow of electron. This hindrance is actually known as resistance of the current. Then in the B part it says differentiate between conductor, resistor and resistance. So conductors are those substances which allow to pass the charges through them very easily because they have less resistance. Now they say resistor. Resistor is actually a conductor, has some value of resistance. Now what resistance is? It is actually the hindrance which is provided by the path of flow of charge. Or you can say it is the property of any conductor by virtue of which it opposes the flow of charge through it. That's why conductor has less resistance, therefore they can allow more electrons to pass through them, whereas in insulators the resistance is quite high, therefore it cannot allow the electrons to pass through them. Let's start with next. So it says a wire of length L and resistance R is stretched so that the length is double. So my length get double. Now in the second part it says area of cross section is halved. That means A has been reduced to A over 2. Now how will the resistance change? We need to find R in this case. So R is rho L over A. The initial formula for this is rho L A. Now putting the value of L dash and A dash respectively, I get L as 2L and my A dash has been replaced with A over 2. Now 2 will go to the numerator. Now we have 4 rho L over A. Now rho over L over A can be written as R. So the change in resistance is 4 times of the initial resistance. Now in the second one it says how resistivity changes. Resistivity won't change as it does not depend on the property of the material of a conductor. So therefore there won't be any change in the resistivity. There will be change in resistance, but there is no change in resistivity. Now moving on to next question. It says an electric kettle of 2 kilowatt works for 2 hours daily. Calculate the energy consumed in SI and commercial units. Cost of running it in the month of June at the rate of 3 per unit. Now we know one formula, that is energy equals power into time. Power is given, that is 2000 watt. Time is given, that is 2 hours. So the total energy consumed is 4 kilowatt per hour. Now we need to find the cost of it. So June has 30 days. So 4 into 30 into 3, the rate of the unit. So the total cost will be 360 rupees in total. Now next one. Two bulbs A and B are rated 90 watt and 120 volt and 60 watt and 120 volt respectively. They are connected in parallel across a 120 volt source. Find the current in each bulb. Which bulb will consume more energy? So first of all we need to find the resistance for each bulb. So for finding resistance we can make use of P equal V square over R formula. Now we have the value for V square and we have the value for P. So from that we can get resistance value very easily, and that is 160 ohm. Now we need to find out the value of current in each bulb. So I1 in this case will be V over R1, and V is given, that is 120. R1 is given, that is 160. So the value is 0.75 ampere. Now similarly for second bulb, you will make use of power and voltage, then you get the value of resistance and you get the value of current similarly. Now they ask you which bulb will consume more energy. So you can see clearly that the first one has consumed 0.75 ampere. That means the power of first bulb can consume more energy as compared to the second bulb. So let's move on to the next one. It says state the formula correlating electric current and voltage applied across it. Also show the relationship by drawing a figure. So that's very simple. That's Ohm's law, and in that you can write that V is directly proportional to I. Then after that you can write V is equal to IR. Then you can plot the graph between V and I, and it should be a straight line graph because as you increase the current there will be increase in voltage. Now the second part of it, it says what would be the resistance of a conductor if the current is there and when the potential difference is there. So you just need to put the value of V and I, you will get the value for R. That's simple. So R value as done here is 4 ampere. 1.4 over 0.35 will give you 4 ampere. Now moving on to next, it says that what is meant by saying that the potential difference between two points is 1 volt. So 1 volt is actually equal to the amount of work done in bringing a unit positive charge from one point to another is 1 joule in an electric field. Then potential difference between the 2 points is said to be 1 volt. So you can write this. Then in the second one it says why does the connecting cord of an electrical heater not glow while the heating element does? Because the connecting cord is made up of has an insulation as well and is made up of copper metal which has low resistivity but good conductivity. So therefore it does not glow. Now in the third part we are given with some electrical resistivity of different elements. Answer the following questions in relation to them. Among silver and copper, which one is better conductor? So is it silver or copper? Then you need to state why. So as you can see the resistivity of silver is 1.60 into 10 raised to power minus 8 ohm, and for copper is 1.62 into 10 raised to. So resistivity of silver is lesser than copper, therefore it is a good conductor. Now second part it says which material would you advise to use in electrical heating device. So in electrical heating devices it is recommended to use nichrome as the resistivity of nichrome here is maximum. So you can make use of nichrome in electrical heating devices. Now moving on to next. It says what do you mean by heating effect of electric current? So when current is passed through a conductor, heat is produced and production of heat is related to the passing of current. As soon as you increase the current, there will be increase in the production of heat. So when a current is passed in a conductor by applying a potential difference, electrons get accelerated and collide with atoms of conductor, and during this collision there is a loss of kinetic energy, and this loss in the kinetic energy appears in the form of heat energy in the conductor. And here it asks you to suggest two devices based on heating effect of current. So it could be electric heater, it could be bulb, and many others. Moving on to next, we have state the commercial unit of electrical energy and find its relation with its unit. So commercial unit of electrical energy is kilowatt per hour, and kilowatt per hour is equal to 3.6 into 10 raised to power 6 joules. you need to write 1 kilowatt equals 1000 watt and R into seconds to get this relation. Now the second one, the current through a resistor is made 3 times its initial value. Calculate how it will affect the heat produced in the resistor. Now the current has been thrice. So thrice square is 9. That means 9 times of it. 9 times of initial heat generated. So find the increase in the amount of heat generated in a conductor if another conductor of double resistance is connected in the circuit, keeping all other factors unchanged. So we have two resistances, that is R plus 2R, which will be 3R. Now H will be I square in bracket 3R in replacing resistance 3R into D. So the heat generated is 3 times the initial heat generated, because we have 3 here, extra 3 here. Thank you for watching this video. Have a great day. Thank you.